Jai Hind and very good morning to all. Today in this lecture, I will discuss introduction to searching and sorting. So first of all, we should know what is searching. Basically, searching is the process of finding the location and value of an element in the given list. And for searching, we mainly use two techniques. One is called linear search, and that is also known as sequential search. And another technique that is used for searching, that is called binary search. And binary search considered more efficient as compared to linear search because it takes less time as compared to linear search. Both are the simple technique, and with the help of example and algorithm, we will discuss these two techniques. Along this, I will discuss introduction to sorting techniques. So first of all, we should know what is sorting. Sorting is the process of arranging the given data elements in some order. That can be ascending order, that means in the increasing order, or that can be descending order, that is in the decreasing order. We have different kind of sorting techniques, and in general, we can divide sorting techniques into two categories. One is called internal sorting, in which we use the internal memory for sorting the given data elements. We can take the example of bubble sort, selection sort, insertion sort, quick sort. All these sorting techniques comes under the category of internal sorting. Another category is external sorting, in which we use the external memory for sorting the given data elements. Why it is so? Because the internal available memory is not sufficient for arranging the given data elements. And we can take the example like mugshot, that's come under the category of external sorting. Now in this lecture, we will discuss about the basic sorting techniques like bubble sorting, insertion sorting and selection sorting. So let me start. First of all, as I told you, we will discuss what is searching. So searching, we can say, is a process, is an operation, or we can say is a technique. And basically, it is used to find the place of a given element or value in the list. Already we have a list, and in that list we have to find the location, or we can say value of the element in the given list. Now, how we will say search is successful? If the element is find out in the given list, then we will say search is successful. Otherwise, we will say search is unsuccessful. Now, some of the standard techniques that we use for searching, as already in the starting I've told, mainly we will discuss two searching techniques. One is called linear search, that is also known as sequential search, and another technique that is called binary search. In linear search, elements can be sorted or unsorted, but in the case of binary search, we can apply this technique only in that case if all the elements are already sorted, whatever technique we are applying for sorting the given data elements. But to apply this searching techniques, all the elements should be already sorted. That is the limitation of binary search techniques, but it is considered more efficient as compared to linear, because always searching area becomes less than 50%, and we will understood with the help of algorithm and its example. So first of all, linear search. First of all, we will discuss about the algorithm. Algorithm, basically, what is algorithm? Algorithm is the set of steps that we use to solve a given problem. Now here problem is we have to search an element in the given list. So what will be the first step? Now in this case, whatever element we are trying to find out, we will compare that element with each element from beginning to the last. If that element is matched with some element, then we will say element is find out on that particular index, and we will say search is successful. If we are not able to find out any matching during the matching, then in that case we will say search is unsuccessful. So then in that case, first of all, start at the first element of the list. That means always we have to start from the first element and compare the current element with the target value. Target value means for which we are trying to find out that key, that value that we are trying to search in the given list. Then we will compare the current element with that key, or you can say target value. If the current element is equal to the target value, that means whatever key or whatever target value we are trying to find out, if this is matched with the current element, then we will say we will return the index of the current element. All the element we will store in an array. For example, this is the array, and for example, name of array is A, then its index will be A0, A1, A2 and up to AN. For example, here we have element 5, 7, 2, 3, 9, 4, 6. So initially, for example, we are trying to search 3. 3 will be, current element is 5 and target value, that is 3. And we are trying to search in this list. Then we will compare with the 5 and it is not matched. If it is matched, then it will return the index, and the whatever value is stored on that index, that will be the value of that element that is matched. If the end of the list is reached without finding the target value, for example, we are searching that element that does not exist in the given array. In that case, what will happen? Search will not be successful. Now, we are comparing each element one by one, first of all with 5 and 7 up to the last element. If that target value or that key is not matched up to the last element, then in that case, we will say search is unsuccessful, and target value, we will say target value was not find out. What are the features? The first feature is that it is used for unsorted and unordered list of elements. That is the plus point for this searching technique, because I have already told in the case of binary search, the limitation is that all the elements should be sorted. Only in that case binary search technique can be applied, but that is not in the case of linear search. We can apply this technique for unsorted as well as unordered small list of elements. Why we are saying small list? Because it will compare each element and it will go compare up to the last element. So it is efficient in case if list is small. If list is large, then it will take more time, and that particular searching technique is not recommended. If we discuss in terms of its time complexity, what is the meaning of time complexity? Amount of time it takes for its execution. Okay. In that case, it is order of n. That means if number of elements are n, then time complexity can be find out in 3 cases. That can be best case, that can be average case, or that can be worst case. What will be the worst case? Whatever element we are trying to find out in the given list, if that element is the last element of the list, or that element does not exist in the given list, that will be the worst case. That means या तो element last element है या वो element list के अंदर exist नहीं करता. That will be the worst case. What will be the best case? In the beginning, as we trying to match, in the beginning we find out the element. That will be the best case. And what will be the average case? That means if number of elements are n divided by 2, that means in between you are able to find out the element. That will be the average case. Because its time complexity is order of n, which means the time is linearly dependent of number of elements, which is not bad and which is not good too. Okay. In the worst case, this, as I told you, if that element is the last element or does not exist, in that case, we have to search up to the last element. In that case, order of n equal to n. That is in the case of worst. What is in the case of best case? In the beginning, for example, we are searching 5, and in the beginning, we find out that element. That is order of n equal to n. So, order of n equal to 1. And what will be the average case? Order of n equal to n by 2. 1 by 2 is a constant. Then in that case, it will be order of n equal to n. Next feature, it is very simple implementation, as already discussed. With the help of these searching techniques, we can implement in a very simple way, and we will discuss it with the help of a program. Let us take an example so that we can get a better idea about the linear search. Now, for example, these are the elements in the given array. The first element is 12, 25, 8, 10 and 32. In the given list, we have to find out 8 with the help of this technique that we are calling linear search. So, as linear search we have discussed, first of all, we will compare 8 with 12 in the first iteration. Because 12 is not equal to 8, that means it does not match, and we will continue. Then we will match 8 with the next element, that is 25. That means we are comparing 8 with 25. Still 25 is not equal to 8, does not match. That means we have to continue. We have to continue until some match is found out, or this is the last element of the given list. That means search is not successful. Again, we will compare 8 with the next element. That means we are comparing 8 with 8. Now here, because 8 is equal to 8, it matches. That means it returns the index of 8. Index of 8 means first element will be stored at index A0. That is A1, A2. A means name of array. 0, 1, 2, these are the indexes. That means 8 is matched. That means search is successful. And it is find out onto the index 2. That's the way linear search works. Now, we will discuss about the algorithm. If we are writing an algorithm for this. Now, here we are discussing algorithm for the linear search. Here we have taken an array and we have declared as a capital A. Array is the collection of homogeneous data elements, or we can say similar type of data elements. That means all the elements must be either all integer, all float, all character. That should be of the same data type. That is the limitation of array. But we can store according to the size of array number of elements. And now, for example, in this array, we are trying to search value x. In the given array, we have to search value x. Now, what will be the steps if we are searching value x in a given array A? First step is set I to 1. We are running a loop with the help of I, and we are setting, that means we are setting onto the first element. Step 2, if I is greater than n, sorry. If I, the value of, for example, initially I की value 1 है, and that is greater than n is the number of elements in the given array. Then in that case, go to step 7. What is step 7? That is print element not found out. That means you have searched from starting searching from the beginning up to the last element, but there is no matching. In that case, what should be printed? That is, whatever element you are trying to search, that is not found out. That means search is unsuccessful. What will be the step 3? If I will vary from 1 to less than 1 to n, then whatever value is I, if it is equal to x, that means some array elements according to value of I, if it is matched with x, then we have to go to step 6. What is step 6? Print element x, because there is a match as we have discussed in the previous example, that is find out at index I. In our example, that was find out at the index 2 and go to step 8. Step 8 is exit. That means there is a match. Then in that case, if there is a match, we can print the index, that is element is find out that index number, and simply you have to exit. Again, because we have to apply a loop, and we will discuss in the next slide with the help of a program. Then if it is not so, then we will increase the value of I by 1, that is I equal to I plus 1. Initially, we have taken I equal to 1, now it will be I equal to 2, and we will repeat the same process from step number 2. Again, we will check the value of I is greater than n, then we have to go to step 7, that is not find out. If it is not, then A2 will be compared to value of x, and the same process will be repeated again and again until there is a match or the value of I is greater than n, that is search is unsuccessful. So this is the algorithm, and based on this algorithm we will implement this in the C language, and we will discuss the program with the help of a program. Now here what we have to do, we have to write a C program, that means in the C language, and we have to find out key element in the list using linear search. That means first of all we will take an array, and in that array we will take the number of elements, we will enter the value of elements, and after that in that given list we will search that particular element exists at what location or what index that we are trying to do. Already, if you are familiar with the C language, that is hash include, that is std means standard input output, dot h indicate the header file, and we need this header file to execute these two, that is printf is the output function and scanf is the input function. So here we have taken an array with name A, data type we have taken integer, that is we are dealing with all integer values, and with the help of I variable we will execute the loop item which we are searching in the given array, and n is the number of elements that we have to given with the help of user. So first of all, with the help of user, we are deciding number of elements in the array, and we are entering with the help of user, and whatever value you will take, that will be the number of elements in the given array. For example, we have taken 8, and in that case we have to enter the 8 values, and we are storing all the values in an array. So we will execute a loop. This is the for loop, and every loop contains 3 parts. First part is called initialization, second part is called test condition, and third part is called manipulation section, that is pause increment and pause decrement, या pre increment या pre decrement. So in that case we are running a loop so that 8 values can be inserted into the array. So that is the our input function scanf, that is the format specifier percentile d, because we are dealing with integer values. So in that case format specifier will be percentile d, and that is the address operator. It will provide the temporary address in the given array to each value, and we are writing a within the bracket I. It will take I value from this loop. Initially, first of all, I will be 0, then 1, then 2, and so on. up to when I is less than n. Okay. So in that way it will execute, and every time it will demand an input. And for example, we have taken the number of elements 8, and with the help of this part, we are entering the elements. For example, we have entered 2, 3, 5, 7, 8, 6, 4, 1, 8 elements. Now, in the given array, what we have to do? We have to search some element, whether that exists or not, or what is the location or what is the index of that element. So whatever we are searching, that is we are calling target value, we will enter from the user with the help of this scanf. Again, percentile d for integer value, that is called format specifier. Item, that is the target value that we will search in the given array, and then again we will apply the loop, and it will start, that is initialization I equal to 0, and it will continue up to I less than equal to n. That means in the linear search we are comparing from the first to the last element. If it is not matched, then we will say element not found out, search is unsuccessful. So that's the reason we have taken I less than equal to n, and that is every time it will increase the value of I by 1. Now in this case, what we are trying to do, as we have discussed, if item, that is the target value, is equal to a of I, initially I will be 0, then 1, then means item, we are comparing this item with the values of array from starting to the end. If this condition is true, that means target value is matched with some value of array. Then what we have to do? Then we have to print this message, that is item is find out, but we have to print the location or index, that is the format specifier, and that is I plus 1. We have taken initially I equal to 0 in that way. So, and after that we will apply a break, so that if this condition is true, and after the execution it will come out from the loop. After that, if it is not happening, if I greater than greater than n, so in that case, every time whenever loop executes, we are incrementing value of I by 1, and if it is greater than n, what it will indicate? It will indicate item does not exist. That means every time you have compared the target value with the array value from 1 by 1 up to the last value, and that is not matched with any value, that will indicate that item or that target value does not exist. In that case, simply we have to print this message, that is item does not exist in the given array. That is search is unsuccessful. So that's we have taken. For example, enter item to be searched. For example, we are searching 1, and 1 exists at the location 8. 2 at location 1, then 2, 3, 4, 5, 6, 7, 8. That means 8 exists at the location 1. So in that way, with the help of this searching technique, we can search an element in the given array, and that is the simplest one. But that is not recommended if the list is very large. It is because every time it will compare target value or item from the first to the last. If list is large, that is not recommended. Only if list is small, that is very helpful. Come to the next searching technique, that is called binary search. Binary search is very efficient as compared to linear search, but the problem is that in case of binary search, it can be applied only in that case if elements are sorted. That means on to the sorted elements only it can be applied. Let us discuss. Binary search is used with sorted array or list. As we are discussing, it can be applied only on that array or list if it is sorted. Otherwise, it cannot be applied. Now, in case of binary search, we follow the following steps. What will be the step? Already element is sorted, and we are not comparing target value with each value. In that case, what we will do, first of all, we will find out the mid value for the given list. And whatever target value or item we are trying to search, we will compare that item or target value with the mid value. With that comparison, if that value we are searching, search will be stopped and we will say search is successful, and whatever index or location mid element has, it will be printed. If it is not matched, then after comparison we will came to know whatever value we are searching, either it will be less than the mid value or it will be greater than. If it is less, then we will came to know that the element exists in the first half of the given array. If it is greater, then we will came to know that element exists in the second half of the given array. If it exists in the first half, then the upper bound will be mid minus 1, because already we have compared with the mid element. If it exists in the second half, then lower bound will be mid plus 1. That's the process in the case of binary search. Let me discuss with the help of an example. Before that, we will discuss what are the features, properties of binary search algorithm. It is great to search through large sorted arrays. If array is large and that is sorted, it is always recommended, because every time we will compare target value with the mid value, and after comparison, the searching area will be, in average, will be less than 50%. So that is best as compared to linear search. If we talk in terms of time complexity, its time complexity is order of log n. That is very good, and that's the reason it is always recommended, and it is efficient as compared to linear search. And if we talk in terms of implementation, it is very simple technique, very simple implementation. Let me discuss. First of all, example. Already we have discussed, but with the example it will be more clear. For example, this is the given array, and these are the elements that exist in the given array. In this array, for example, we are trying to search 38 with the help of binary search. Now, 38 will not be compared with the first element. According to binary search, what we have to do? First of all, we will find out the mid element. So, how to find out the mid element? First element is stored at the index 0, last element at the 10, and divide by 2. That is 5. That means in that case, mid element is 23. Now we will compare 38 with 23. Because 38 is greater than 23, then we will came to know that searching element exists in the second half. That means we will come to this part. Again, we will repeat the same process. What will be the process? We will find out the mid element. So, what will be the mid element? In that case, 72 will be the mid element. Lower bound plus upper bound divided by 2. Again, we will compare 38 with 72. 38 is less than 72. That means that exists in the first half. That means this part. Again, we will do the same thing, and 38 will match this element, and you can say search is successful. Always in the case of binary search, we will find out the mid element. Mid element is compared with the searching key, or you can say target value, and after comparison we will came to know that element exists in the first half or second half, and we will repeat this process again and again. If it exists in the first half, then always upper bound will be the mid minus 1. If it exists in the second half, it will be mid plus 1. Let me discuss this with the help of an program. Here we have to find out the key element or target value by using binary search that we have discussed. Now in this program, what is happening? Already we are familiar about this library, that is standard input.h, that we use for the, already we have discussed printf and for scanf. We are using one more library that is called conio.h, console input output. That is used for the, you can say that is used for get ch or clr scr if we want to clear the screen. So that is the role, and with the help of this get ch we can freeze the output on the output screen until unless you are pressing any key and you are coming to the main screen. In this case, what we are trying to do, we have taken a variable I, and what is the role of I? We will enter the elements with the help of a loop. Okay, let me check. Then we have taken an array and size is 10. We will store all the elements in the array. Search, for example, we can take some key or we can take some item. These are the first, last and middle. That is the lower bound, that is the upper bound, and we have to find out the mid of an array. For example, we are not in general, we are taking elements. We have fixed. For example, in an array, we are entering 10 elements. And because we are entering elements and in the ascending order, because if the limitation of binary search is that all the elements should be sorted. It is the for loop starting from I0. That means first element will be stored array 0, then array 1 and up to the 9. Because we are taking 10, then loop will be executed from 0 to 9. That is I less than 10. And using this statement, we are giving the input as we have already discussed. Then we will enter the element for which we are trying to search in the given list. We have taken the variable search, and first, that is the lower bound, we have set up to 0 because we are taking from 0 to 9, and the last, that is upper bound, it will be 9 in that case. If we are taking n elements, then it will be n. First of all, we have to find out the middle. Middle will be the first plus last divided by 2. With the help of this, we will find out the middle. Now, we are checking this condition. While first is less than equal to last, always it will be true. Then if it is true, then it will enter here. If array of middle, already we have find out with the help of this, is less than search, then in that case, as we have told, the first will be middle plus 1. That means that exists in the second half. Now, first will be middle plus 1. Else, if middle equal to search, that means that is match with that searching element. And if it is match, then simply we will print that element and we will put a break. Already we know the meaning of break, that it after execution, it will come out from the loop. If it is not so, that means element exists in the first half, then last will be middle minus 1, because already we have compared with the middle element, and again because it exists in the first half, again we will have to find out the middle, and middle will be the first plus last divided by 2. So with the help of this, we are able to find out middle. If first is greater than last, then in that case, what's the meaning of this? That means that element does not found or does not exist in the given array. For example, we are trying to search that element, whatever element we have entered, that is the different element, and that element in that case will not be find out. If we execute, already we have decided 10 elements, then we have entered the values of 10 elements. For example, in the given array, we are searching 15. Already we have discussed the limitation of binary search is that all elements should be already sorted. That's the reason I have put it in the sorted form. In that we are trying to find out 15. Already 15 exists. If we take the position, or you can say location, that is 1, 2, 3, 4, 5. That means 5 and 6, because we are trying to find out 15. So 15 exists on the position 6. So that is about the searching techniques, that is linear search and binary search. Now I will discuss about the sorting in the next lecture. Thank you.